So let's talk about the electron. So, in chemistry, really in science, we talked about the scientific method. We know that people are going to have to do these experiments to figure out these different theories, etc., and find and discover these new things. So let's talk about one of those scientists, J.J. Thompson. Okay, so J.J. Thompson performed experiments to probe the properties of cathode rays. So you don't know what a cathode ray is. This is basically what it is. We got our voltage here running through this cathode ray. So we got our negative side, which is the cathode, positive side, which is our anode. And this is a glass tube. It's completely evacuated, so there's nothing in the glass tube. The only thing that we're going to see in the glass tube is this cathode rays that are going back and forth between the cathode and anode. Okay, so this is what it looks like here as a picture. Okay, so we're just going to cover a couple things on this. So basically, when Thompson was doing these experiments, all right, he basically figured this out. Just to sum this up, he realized that these rays, right, that were going back and forth, had an electrical charge. All right, that's what we ultimately found out thanks to these experiments doing that scientific process, right? So that ray, as we see here, the ray, all right, it was coming from the cathode. All right, the cathode was repelled by the negative charge. So those things that were being repelled, we ultimately found out that they were these small, tiny particles. And in this case, we didn't know this at the time. He didn't know it. But those particles were electrons. These were actual electrons. Okay. So he basically did this charge to mass ratio of the electron. All right. And he found out that it was a negative 1.76 times 10 to the 8th coulombs per gram. Okay. So basically, this is just units. All right. Just to put that out there. This is the charge by mass. Okay, so as it says, charge to mass ratio. So because it's a charge to mass ratio, you want to make sure your units are with that. So this coulombs per gram. Okay, so basically when he found this out, right, this is a huge thing, right? So this stated at the time that this meant that this particle that he just found out about was actually lighter than hydrogen. So that's really big, right? Because at that time, during this time, people assumed and thought that hydrogen was the lightest thing basically in the world, right? It's the lightest element, the smallest element. So there was no like other type of particles, right? During this time. But he found out, right, with these electrons, there's electrons that exist and they're actually lighter than the hydrogen. So in this history lesson here, right, 1909, another guy, Robert Milliken, he calculated the charge and mass of the electron. All right, that's what he did with this experiment here. He has a microscope where he's able to look at oil droplets. Okay. In these oil droplets, right, he's going to spray those oil droplets across this positive charge plate to where we're going to see that it falls through. But we have this ionizing, right, radiation. All right, so this radiation is going to be giving that energy to these droplets. And at the very bottom here, we have a negative charge plate. So what he saw, right, during this entire experiment, right, as he shot those droplets, they went through, bam, next thing you know, they got hit with this radiation. And guess what they acquired during this time? They acquired the electron. Okay, so that's what they were acquiring. These oil droplets were getting that energy, that electron. So what happens when you get an electron, right, in these oil droplets? He started to notice that, well, those charged oil droplets are being suspended in the electric field, right? So they started being suspended. They're not going down, they're staying up, right? And that's because, right, if the oil droplets have electrons, which we know now, right, are negative charge, that these negative charge things will be repelled from the negative charge plate. And that's what we saw here, right, with those oil droplets being suspended. So basically he found, that the charge was always a whole number of a multiple of negative 1.6 times 10 to the negative 19 coulombs, right, which was the charge of the single electron. He also was able to find the mass of the electron too, thanks to Thompson's mass to charge ratio, okay? So once again, that's just a quick history lesson of the electrons.